Hey guys, welcome. This is my first video and I'd like to start a series of videos speaking about how to build a better software. And in this video, I'd like to answer a few questions such how to manage complexity inside your system, how a bad system design can make your life a hell, how a good software architecture can help you manage complexity, and how design patterns are related to it. What is the importance of the business context inside all of this? So let's begin.
It starts with
Okay, so how to describe complexity? Complexity is about how hard it is to make changes on your project. It's about how hard it is to make the maintenance of the project. It's also about how hard it is to add new features. So imagine you are starting a new project from scratch. How hard it is to implement the modules, the business rules, and all the requirements. How about if you have a project in production right now and you have to make the maintenance? How hard it is to make changes? Those are good questions to start to understand complexity in software development. So according to Wikipedia, uh, complexity is a term that includes software properties that affect internal interactions. Wikipedia is a good source. You can trust Wikipedia sometimes. And there is a difference between complex and complicated. Complicated implies being difficult to understand. How hard it is to understand that code. That's a complicated code. But complex describes the interactions between entities. So as the number of entities increase, the number of interactions between them increase exponentially, making it impossible to know and understand them all. We are talking here about the natural life cycle of software development, of the software, because softwares are made to fulfill business requirements, and business is always changing. So we can be sure that the software will always grow, will always change, and the number of entities will always grow as well. And complexity is always growing together. It is the natural cycle of things. So let's go back here to the board. Okay, so when it comes to complexity, I also like to classify software inside three categories: side projects, startup projects, and enterprise projects. Side projects usually are projects that you work on in your extra time. You have your job and you want to make some extra money, or you want to help the community to solve a very specific problem. Then you start work on these extra time projects. Usually you work on small teams, or this can be also a single person project, and usually you have a small scope. As I said, you are trying to solve a very specific problem and provide a very specific solution. So that makes the software less complex because you have a goal, you have a small scope. That's usually how side projects works. It is a little bit different when we work inside startup projects. Usually a startup is focused on innovation. So you also have small teams, but usually the number of members is higher than the side projects. And you have a tight budget because you depends on the investor money, and the budget is not that high. Because of that, you have a small team, right? And you have to rely on rapid development because you are trying to reach the break-even point. So you have a tight timeline, and you have this deadline to reach the break-even point. So that's why the engineering team usually goes with a rapid development and try to create a MVP as quick as possible and get clients as quick as possible. And because all of that, you have more responsibility for each person. As I said, we have a small team inside this kind of company, and we also want to worry about scalability because we are getting new users, new clients every day to reach our goals. So we have to worry about scalability as well. How about enterprise projects? Here, the game changes because you are working for a large company, and usually the software touches every department of the company, and we can have a lot of departments. That means a lot of business rules as well. So you have probably a large engineering team. That means that there are a lot of people touching the same code base. You are not dealing with that small software anymore where you can manage all the change. Here you probably have inside the engineering team squads with 5 developers, 10 developers, like 10 squads with 10 developers, each one touch the same code base. Imagine that. How you will manage the change. You have comments getting every day. You have deployments every day to production. You have to rely on a process. You have to rely on standards. Because if you don't do that, things can go wrong very easily. And because of that, you have this robustness. The software usually are large softwares. And for sure, scalability is a requirement for sure. And we also many times have to worry about security because usually big companies deals with sensitive data, so you have to protect the data. Which system design is better for security? That changes this kind of property changes how I should build my software. Okay, so let's take a look right here. Let's talk about software lifecycle. I'm using the same examples from the last chart. Here you can see the side projects, startup projects, and enterprise projects. And why do I have that order? Because usually that's how things works. Your side project can become a startup project, and that startup project can evolve to an enterprise project. That's a very common use case, and of course, you could start your company as a startup directly, and you could also start your company as an enterprise company. That depends of how much money you have, but you see a lot of cases where people start a small project and that becomes a very successful use case, a very big company in a few years. Let's use this example to understand something. And I want you to understand that the technical decisions in your software that you make right here can reflect when you migrate to this level, and it could also reflect at this level as well, even if it takes like five years. That can happen. It's very common to see that. And I can say for myself, I've been working in a lot of projects in the past few years that someone back there decided that, for example, component A will be too nested, too coupled with component B. And guess what? Now the product managers want us to change the behavior of component B because the business needs that, and they asked us. This is the new requirement, and we should make a huge refactor on component B. But we have component A too coupled with component B, so we will have to make the refactor on component A as well. That's how it works. And guess what? Component A is a core component, and more components are nested together with component A. And you have like less than 40% of test coverage. That means that you don't have ways to test your code after the refactor. That means you will have to make a regression test manually with your QAs engineers. So you will have to allocate engineers to make the refactor here, and probably more modules as well, and QA engineers to make regression tests on component A and component A and component B. So look the size of this mess. This will take a lot of time, and that will probably cause some problems to the final user, the customer, because you don't have ways to know if the QA test was good enough, because regression tests sometimes are not 100% reliable. This could be avoided if someone back here had make the right decision. So what engineer should do here? If the engineer knows the possibility of complexity to grow, the engineer should decouple things. And I'm not talking about over-engineering, because we know that on side projects we have a small scope and a small team. But I'm talking about good practice, such as choosing a modular approach to start creating modules for each component of the business. That way you can create boundaries and make things a little easier in the future for changing. That's the whole idea of the coupling. And that's what I want to explain about this life cycle. Okay, a decision can be good right now. You can choose to do the easy way. Oh, why to choose a complicated approach if I could do just this on that, or use the framework approach to use this or that? Okay, fair enough. I agree that it is easier, right? But the easier way is not always the correct way. You've got to make decisions based on the whole context, even in the future. That way you can avoid to spend money with refactors, with bugs, and so on. And yeah, don't forget to create the unit test as well, please. Okay, let's keep going. Okay, so let's talk a little about how to make a good choice when it comes about system design. Uh, well, you could go with the monolith approach, the microservice, or the event-driven design approach. If I would start a side project, I would probably go with the monolith approach, because that way I would have to handle less deployments, because the front end and the back end are all together. And these make the deployment easier because you have one single deployment, probably to a single server, at least at the beginning. As I said, this is about a side project. But if I knew that I would have to handle more requests per second, I could scale in a horizontal way, adding more nodes to a load balancer, for example, Monolith works the same as microservers when it comes to horizontal scaling. And I could go with the vertical scaling as well, increasing CPU and memory and storage and so on. It's a very good choice as long as you can keep your code organized, because if you have a lot of people work in the monolith, things can go south very easily and the code can be too nested and coupled very easily. So be careful. And how about microservers? Microservers, you have a way to distribute complexity among nodes, among servers, microservers. For example, you have a consumer here and an API, a REST API right here, the microservers. It's nice because usually you have small microservers that deals with a specific functionality. You have like the single responsibility principle here, because that service will handle only a very specific part of the business. That's great. That helps a lot. I like this concept, but the thing is, the drawback here is that when you make changes on the API response, for example, all the consumers are going to be affected. So yeah, you have more than 10 nodes that depends on this response. You will have to make more than 10 deployments to fix this problem. So the complexity increase throughout the network. So that's another kind of complexity to handle. You have to know those drawbacks and know how to handle those situations. How about event-driven design? I think this is the state of the art when it comes to decoupling, because you have now a broker of messages that handle events. You have a producer to make the event, and you have the consumer to consume the event. And the good thing here is that whenever you need someone else to consume the same event, you can add a new consumer here. So consumer 2. And this guy will be able to consume the same event. So let me put right here and put this thing right here. So this guy produced the event, and everyone attached to that broker that is listening to the same event will be able to consume. That's great because I can increase the complexity without affect the other nodes. So that's the state of the art when it comes to the coupling. That's nice for large companies that for enterprise softwares, because you are able to distribute the complexity and among the network without affect any node. So it's very easily to attach and detach servers here. The drawbacks would be the cost. It is too expensive to, sometimes it's very expensive to have a structure like that, but it is great. Okay, so I want to finish this video speaking about software architecture. And when I say architecture, I mean the code design itself, the internals. System design is about the big picture, but software architecture is about the internals, the code design itself. We have a few here: the modular, clean architecture, ports and adapters, layered architecture, also known as N-tier architecture, and the domain-driven design. We also have more, but those are the most famous ones, and each one of them is great to decouple your software to take your business components and split inside modules and create the boundaries between them in order to make your software to grow healthy. And they are great. as I said in the beginning, at the beginning of this video, I would like to start a series of videos speaking about how to build better softwares. And I was speaking about those guys here. I want to make a video to talk about the modular approach, the clean architecture approach, the ports and adapters. I wanna get all the pros and cons, and I wanna make practical implementations so you can see and take your own conclusion, and you can form your own opinion about each one of them. The ones that I use a lot in my daily basis, it is the modular one, the clean architecture, and the layered architecture. But I have experience also working with domain-driven design and ports and adapters. They are great as well. But recently I've been working on smaller projects, so I rather go with a more straightforward approach, like the layered architecture, where I can work with servers and the repository pattern as well, or the modular one where I can, without having to decouple things from the framework I work with, I can do things and decouple at least the business components, and works great as well. So yeah, I think I hope actually I could I could deliver the message here, um, and give you the big picture idea of how complexity works. That complexity may not be visible right now, but the software can grow very fast and things can go south very easily. So you have to be aware how to handle those situations and how to make the good decisions right now. So yeah, that's me. Subscribe, leave a like, and see ya. Bye bye.